So now we see some different problems, so which are also based on the ideal gas equation. So these are treated as total applications of ideal gas equation. Okay, see the first one. What percent of a sample of nitrogen must be allowed to escape if its temperature, pressure, volume are just changed from 220 to temperature is changed from 220 to 110, pressure changed from 3 atmosphere to 0.7, volume changed from 1.65 to 1 liter. Then what is the change in its mass? Nothing but mass in terms of number of moles. So by number of moles and mass direct given this, the what percent of sample of nitrogen must be allowed to escape. Okay, at the sample compound sample of compound అంటే in terms of moles though, what must be difference at these conditions and at these conditions. Okay, now we take the first conditions as P1. So P1 how much? 3 atmospheres. What is the volume? 1.65 liters. What is the temperature is given? 220 degrees Celsius. 220 degrees Celsius means by changing it into become 293 Kelvin. So what is the second condition? Actually the gas is changed from this conditions to these conditions. Here say the number of moles and one is equal, just we are taking as a number of moles are 1. Okay, no need to calculate the exact number of moles, just we are going to calculate only the percentage value. Just different stage ko man percentage chestam kabatti endalo manaki exactly telavalsina avasaram ledhu. Okay, and no need to know the exact value of number of moles because we are calculating only percentage. So that gas is changed to P2. What is the pressure at second time? So its volume becomes 1 liter. What is the temperature becomes? The temperature becomes nearly 110 degrees Celsius. 110 degrees Celsius means 383 Kelvin. Here what the number of moles? We don't know this number of moles. Okay, so with the help of these all values, first we write the general equation, that is PV is equal to nRT. So the n equal we can write PV by RT. So write it for initial conditions. Okay, write it for initial conditions. N1 equal P1 V1. R value common, no need to substitute the exact value. In the same way, just substitute N2. N2 equal, you can write P2 V2 by RT2. So what is the P2? 0.7. What is the T2? Sorry, V2. That is 1 liter. By R value same. What is the T2? 383. Okay, just by doing N2 by N1, you can do N1 by N2, no problem in it. .7 and become exactly reverse. Okay, here R or just wait, R or get cancelled, and this all calculations we will get approximately here 0.7. Just wait. .7 into how much? 493. Then what is the denominator? Approximately 1895.8. So on this overall calculation, so we will get 0.182. As we know, n2 is equal to 1. N2 is equal to 0.182. So what is N1? That is 1. So what is the fraction? What is the change? Must be escape. For conditions are changed, but some gas will be changed. What is the change? Change N1 minus N2, that is 1 minus, sorry, it is 0.182. And here it becomes approximately 0.818. Okay, 0.85 moles of gas is escaped outside. So we need to calculate in terms of percentage. So 0.818 into 100, that becomes 81.8 percentage. Hence, when the nitrogen gas is escaped from this condition to these conditions, the 81.8 percentage of gas is escaped out. To exist at these conditions, it is necessary to it to escape some of the gas. Okay, right now. Okay, see the total different problem. So a quantity of hydrogen gas occupies a volume of 30 milliliter at a certain temperature, pressure, which are not mentioned here. But what volume would half of this mass of hydrogen? Means here it mass become half, which occupy at triple of initial temperature and 1/9 of initial pressure of what is the gas. So we need to find out the volume part. What volume makes the mass of hydrogen half and its temperature triple and its pressure 1/9. Okay, see the given conditions at initial position. What is condition? Say P1 is not given at some pressure, say it is P. What is volume? It becomes 30 milliliter. Okay, so what is temperature is not mentioned, just take it as T. Okay, then we need to do what is the volume? Here just number of moles N1 equal to take n number of moles, because here we don't know the mass. So as mass is changed means number of moles also changed proportionally. So mass ఎన్ని parts change అవుతుందో number of moles కూడా అంతే change అవుతుంది. కాబట్టి number of moles తో చేద్దాం. Okay, so number of moles starting ఎన్ని అనుకున్నాం, n moles తీసుకున్నాం. So we need to find out what value which makes its pressure 1/9 of its initial pressure, means P/9. What is its temperature? T2. Temperature is triple to the initial temperature. Initial temperature which is T become 3T. What is the number of moles? Number of moles, but we are taking the number of moles in the part of in the place of mass. Mass ఎంత ఇక్కడ half of this mass means n1 equal to n2 is equal to n by 2. Okay, so we know the ideal gas equation. PV is equal to and RT. Here we know the R equal, we can write what? So all values we know, we just know about the V2 value. Okay, make it R is equal to PV by RT. Okay, so we know R value for it, all conditions, there is no change in R value. Now write it first. So here we can write P1 V1, sorry, there is no need of R, and R is equal to PV by NT. So P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. P1 P V1 how much? 30. N1 how much? N. What is T1? T. What is the P2? By 9. What is the V2? We need to find out that. What is P? Sorry, N. That is half. Half of its initial mass. What is T2? That is 3T. Okay, just cancel which are able to cancel, and then get cancel, pressure cancel, temperature get cancelled. So finally we need to get what is V2. Okay, so now what is the V2? So again we are just writing it again. That V2 becomes what is 2V2 by 27. So what is the V2 becomes? And finally we will get this 405. So this is the volume of hydrogen gas, which makes its pressure P by 9, its temperature triple, its mass by 2. Okay, means when these conditions are changed to these conditions, the volume of 30 ml of hydrogen increased to 405 milliliter. Okay, okay, see the next one. So here a 10-liter cylinder of oxygen present at 4 atmosphere and 17 degrees Celsius, okay, is present and is developed a leak in that cylinder. Okay, cylinder low a leakage was formed. So when the leak was repaired, 2.5 atmosphere of oxygen remained. Means during the leakage some gas is leaked. Okay, at first in 10-liter volume, 4 atmosphere pressure, at this temperature there is a formation of a leak. Due to that leakage some gases went outside. So due to that leak, after that leak was totally repaired, so there is a remaining of 2.5 atmosphere of oxygen remained in the cylinder, but there is no change in temperature. Then we need to find out how many moles of gas was escaped. Means the pressure is totally changed. Pressure is changed from 4 atmosphere to 2.5 atmosphere. Okay, if and there is no change in temperature, so we need to find how many moles of gas is escaped outside. Okay, so here after leakage, okay, there is a 2.5 atmosphere. So first take the given conditions. Okay, given conditions again to P1 equal how much? 4 atmospheres. What is the V1? That is 10 liters. What is T1? 290 Kelvin. What are the number of moles? No separately given. Just take it as a number of moles. Take as just 1 mole. Okay. Just for the calculation purpose, only the how many moles. Just we are comparing here. Just take it as 1 mole. So here again, wait. Is there given any number of moles? 290 Kelvin. Just wait. So P2 equal to what are the conditions? 2.5 atmospheres. There is no particular value. There is no particular values given for P2. Means if you know, by changing the temperatures and pressure, generally there is no change in the value. So take it as 10 liters. And it also mentioned that there is no change in temperature. So the value is no change. What is temperature again? So what is the N2? Here we need to know the difference between a number of moles of second conditions and first condition and the comparison. So in the earlier problem, it was only to calculate the percentage. So the earlier problem though percentage calculate చేయాల్సి ఉండే. So కాబట్టి ఇక్కడ just 1 తీసుకున్నాం. ఇక్కడ just we got a value. So by subtract this we got the change and change to change percentage. So ఇక్కడ మనకి exactly how many moles escaped అవసరం. How many moles escape percentage నార్మల్గా n తీసుకుంటాం, ఇక్కడ n2 వాల్యూ వస్తుంది. సో డిఫరెన్స్ ఫైండ్ అవుట్ చేసి పర్సెంటేజ్లో కన్వర్ట్ చేస్తాం. బట్ హియర్ ఇట్ ఈస్ ఆస్క్డ్ ఎగ్జాక్ట్లీ హౌ మెనీ మోల్స్ ఆఫ్ గ్యాస్ ఈజ్ ఎస్కేప్. ఎంత ఎస్కేప్ అయింది అంటే స్టార్టింగ్ ఇక్కడ ఎంత ఉంది, ఫైనల్ ఎంత ఉంది, వాట్ ఇస్ ద చేంజ్. నౌ వీ క్యాలిక్యులేట్ ద ఫస్ట్ వన్, సెకండ్ వన్, అండ్ బై సబ్స్ట్రాక్టింగ్ దెమ్ వీ విల్ గెట్ ద how much gas escaped. Okay, so with the first details we can write P1 V1 is equal to N1 or T1. So what is N1? P1 V1 by R T1. Okay, what is the P1? 4. What is the V1? Let's make it R. So atmosphere liter just we take as 0.0821. T1 290. So we need to do total calculation. So here we get approximately 4 divided 2.38, and finally we will get 1.68 moles. Okay, then what about N2 conditions? Nothing but first, second conditions. Same, we will get the P2 V2 by RT2. So what is the P2? V2 how much? R, no change. P2 is a no change in temperature, exactly same. And here we will get and here on calculation, okay, we will get 0.0821. So already we know that calculation here, okay. So already we have that calculation. That is 2.381. So that is 2.5. That is equal 1.05 moles. So at first these are 1.68 moles. Means at these conditions, so N1 you got how much? 1.68 moles. In N2 you got 1.05 moles. Means by changing the conditions, the number of moles changed from 1.68 moles to 1.05 moles. But in this problem, finally the question is, what is the change in number of moles? Okay, the moles escaped. Moles escaped. At first, what is the number of moles? That is 1.68 moles are there. So finally it remaining how much? 1.04. So how many are remaining now? That is 0.063. So this much of gas is remaining after the repairing of the cylinder. Okay, see the again different problem. So an open vessel at 25-27 degrees Celsius is heated until 3/5 of air in it is expelled outside. So assuming that the volume of the vessel remain constant, so there is no change in the volume of the vessel. So find the temperature to which the vessel has been heated. Means so at 27 degrees Celsius some amount of the air is present. So after it is heated, 3/5 of the air is expelled outside. So now what is the temperature in that vessel? So value is changed here from some any amount 3 by 5 part, so minus అయిపోయింది. So then what is the change in temperature? So starting temperature given at 27 degrees Celsius, and what is the volume? No change in the volume. Volume is no change, and it is an open vessel, so there is no change in the pressure, no change in the volume. Okay, so here the main point is no change in the volume, as it is open vessel, that's why there is no change in its pressure. So now we use this condition for the calculation. For the initial calculation, we know the PV is equal to N1 or T1. So the PV is equal to, what is the N1? How many number of moles are? Just take it as a 1 mole. Okay, just take it as 1 mole. Just we need to the percentage is given, not the exact value. Take the R value, so which is going to be exactly cancelled, but no need to calculate. What is the temperature? 27 degrees Celsius, 300 Kelvin. So here you got 300 R. Next, for the final conditions, okay, for the final conditions, same PV is equal to N2 or T2. So PV is equal to, what is the N2? So here N2 is given, the 3 by 5 part is expelled out. Starting entry is now we took as a 1 mole. So 3 by part is removed. So what is the 3 by part? What is the 3 by part in 1? So there is a 1 minus 3 by 5. Okay. 3 by part is removed outside. So 1 minus, what the 3 by part means? 1 minus 3 by part. So that it becomes 2 by 5, and then it becomes 0.4. So after expelling 3 by 5 parts, how many parts will be remained? 2 by 5 parts will be remained. So what is the 2 by 5 parts means? 0.4. Just make it R only. T2. We need to find that T2. So therefore PV is equal to, that is T2 into 0.4 R. So both are for same gas. Okay, both are for same gas. So here both values are equal. PV is equal to 300 R, PV is equal to T2.4 R. So make it equation 1, equation 2. So by equalizing these two, how they are equal? 300 R is equal to T2 into 0.4 R. So which values get cancelled? R or get cancelled. So the what is the T2? by 0.4 by 4. So here finally approximately we will get what is the temperature? Nearly 750 Kelvin. Okay. So means so by changing the temperature 27 degrees Celsius to 750 Kelvin, the 3 by 5 parts of is expelled outside. Okay, due to the 3 by 5 parts of air is expelled outside, the remaining is how much? 2 by 5 part. A 2 by 5 part ఉండాలంటే ఏ టెంపరేచర్ మెయింటైన్ చేయాలి? 750 Kelvin. Okay, so this is one of the best application of ideal gas equation.